Alright, in this video we're talking about vectors, and I'm aware this will be a new concept for many people. So a vector is basically kind of like a number, but it has a direction as well with it. So scalars are what just normal numbers are called, and then vectors has a direction. For example, if I say that I'm going to walk a distance of 2 kilometers, that's a scalar. But if I say I'm going to walk 2 kilometers northeast, that's now a vector because I've given you a direction as well. Now, the way vectors work is you can define them by just talking about 2 points. So if I walk from O to A, that would be called the vector OA, and we normally draw an arrow over the top of it. But sometimes we like to give them lowercase letters, and if you do that, you've got to write it in bold. Now, I don't know about you, but I've never been able to handwrite something in bold, so that's not really a possibility. So you often write it with a little arrow over the top. Or you can write it with a little squiggly tilde underneath. I actually prefer this one. But a lot of textbooks will say this one. So just be aware that you'll see both quite often. But in books, it'll be written in bold. You'll write it with a squiggle underneath. So we need to talk about visual representation of vectors. Here's a vector. It's got a length of 2, and it's pointing right. So vectors, the things that you care about are how long they are and which direction they're pointing. The arrow on the end shows you which direction it's going. Two vectors are equal if they have the same magnitude and direction, so the same length and direction. So these two vectors A, even though they're in different spots, are still equal to each other. And if you want the negative of a vector, well, you flip it. Okay, so let's do an example here. A force is pointing northeast with a magnitude of 10 newtons. Draw this as a vector V on the diagram. So we're going to point it northeast, and we're going to try and make it a length of 10. I don't know if that is or not, but the point is it's at 45 degrees. So we're going to draw minus V on the diagram too. So if this line here was V, then minus V will be pointing the other way with a length of 10 newtons. There we go. Now, if you want, you could have also had minus V just line up with V like that, right next to it. That's also perfectly valid. Okay, so draw the point 3, 4 on the diagram below. So here's 3, here's 4, here's 3, 4. Standard Cartesian plane stuff. Now, the difference between that and the vector is going to be the length going up to that point 3, 4. So you'll often see it written like this, V equals 3, 4 with square brackets. And that's how I prefer to write it, just because it's easier to type out and looks nicer. But you'll actually see a lot of textbooks write it vertical, 3, 4, just like that. So be aware there are both methods, they both mean vectors. Either way, it's supposed to look different to a point which uses round brackets and is horizontal. So it's actually true, this is the vector V here. But if I had drawn the vector starting over here and going up 4, this thing here is also V. It doesn't matter where you start and end, you can do it any way you want. So I could go here, that's also V. I could go here, that's also V. I could go here, that's also V. And if I go here, that's minus V. So that's what vectors look like. It doesn't matter where they are, it just matters how long they are and where they're pointing. The other thing you can do with vectors is kind of write things in terms of your smaller vectors. So here I would have PQ is the vector A, just like that there, and QR is the vector little b. So if I wanted to write QP, well, that's going from Q back to P. That's going to be minus A. If I wanted to write RQ, well, that's going back from R to Q. That's going to be minus B. If I wanted to go from S to R, well, this is a parallelogram, so this is also going to be A. And S to P will be going from S back to P. That's going to be minus B. Now, you can do funky stuff as well, like if you want to go from P to R, which is that vector there, all you need to do, PR, is to do A and then do B. Pretty cool, but we'll talk more about vector addition next time.